Have you ever thought about the invisible glue that holds our universe together? I'm talking about the fundamental way everything is built, from the water in your glass to the very air you're breathing right now. Today, we're diving into the incredible world of covalent bonds. You know, at its heart, chemistry is really just a story about connection. And it turns out, just like us, a lot of atoms out there are, well, they're looking for a partner. They have this drive to team up, to share, and to become more stable together. It's kind of funny, right? It's a universal need, even at the atomic level.
So that's the real question, isn't it? I mean, why can't these atoms just exist happily on their own? What's going on that makes them so unstable? What's the big drive to find a partner?
Well, it all comes down to one single fundamental mission that pretty much every atom shares. It's a quest for stability.
Okay, so here's the problem. Think of an atom like a tiny little solar system. You've got electrons orbiting in these layers, or what we call shells. Now, for an atom to be stable, to be happy basically, its outermost shell needs to be completely full. But for a whole lot of atoms, it's just not. And those empty spots, that's what makes them reactive, unstable, and always looking for a connection.
And this is where they get clever. Here's the solution they've figured out. If you can't fill your shell on your own, why not find a neighbor who's also got some empty spots? And just share. By pooling their resources, both atoms get to feel like they have that stable, complete outer shell. And that act of sharing, that's the whole idea behind a covalent bond.
Okay, that sounds pretty simple in theory, but how does this sharing actually work? Let's get into the mechanics of it.
So, officially, a covalent bond is a chemical bond where two atoms share a pair of what we call valence electrons. And all that means is they're sharing the electrons from that all-important outer shell we were just talking about.
This is a perfect example. Look at two hydrogen atoms. Each one has only one electron, but its first shell needs two to feel full and stable. So what do? They come together, they share their two electrons, and boom, you get a super stable hydrogen molecule, H2. Now each atom gets to feel like it has a full outer shell. It's a win-win.
Now there's a really important rule to this whole game. This special kind of partnership, this covalent bonding, it almost always happens between nonmetal atoms. You can think of them as the natural sharers of the atomic world.
And they're actually really easy to spot. If you pull up a periodic table, you'll see all the nonmetals. We're talking about things like hydrogen, carbon, nitrogen, oxygen, chlorine. They're all kind of grouped together over on the right-hand side. These are the elements that are building the very molecules of life, all by sharing electrons.
But here's where it gets even more interesting. Not all sharing is created equal. You see, depending on how many electrons an atom needs to feel stable, they can form different levels of partnership. Let's look at the different kinds of deals they can make.
First up, you've got the simplest deal on the table, sharing just one pair of electrons. This is what happens when two atoms each just need one more electron to be happy. So they agree to share one pair. That's it. Simple, effective. We call that a single bond.
And chlorine is a fantastic example of this. See, a chlorine atom needs just one more electron to finish its outer shell. So, two chlorine atoms get together, each puts one electron into the pot, and they share that pair. Just like that, they form a stable single bond, and both atoms walk away satisfied.
But what happens when an atom is missing two electrons? Well, sharing just one pair isn't going to cut it, right? They need a much more serious commitment. And that is exactly the situation with oxygen. Each oxygen atom is two electrons short of having a full shell. So, when they team up, they don't just share one pair, they share two pairs of electrons. And this stronger connection, that's what we call a double bond.
And yeah, it doesn't even stop there. For the atoms that are really in need, they can form the ultimate partnership. We're talking about the tightest, strongest covalent bond that exists. For this, we need to look at nitrogen. Each nitrogen atom is missing 3 electrons. So to get stable, 2 of them get together and share a whopping 3 pairs of electrons. This creates an incredibly powerful triple bond. Seriously, it's one of the strongest connections in all of chemistry. Okay, so we've got the basic rules of sharing, right? Single, double, and triple bonds. So what? Well, let's see how these simple rules literally construct the world all around us.
I mean, just look at this stuff. An oxygen atom shares electrons with 2 little hydrogen atoms, and you get water, H2O, the stuff we drink every day. A carbon atom shares with 4 hydrogen atoms, and you get methane, CH4. It's amazing. These simple covalent partnerships, all based on that one need for stability, are the literal building blocks for the most essential molecules of our world.
All right, as we start to wrap this up, let's just pull all these ideas together and think for a second about the power of this fundamental connection.
So, what's the big takeaway here? It's pretty simple, really. A lot of atoms start out unstable because they have incomplete electron shells. To fix this, they team up with other nonmetals and share electrons. This sharing creates what we call covalent bonds. And those bonds, whether they're single, double, or triple, are what build the absolutely incredible diversity of molecules that make up our entire world.
It really makes you think, doesn't it? This whole complex, beautiful world is built on a simple principle: finding stability through sharing. It's such a powerful idea. It starts with atoms, but hey, maybe it doesn't have to end there.